Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 10 from the Smith Organic Chemistry textbook. And this problem asks us to do several different things. So we're asked to draw the structure of all constitutional isomers that contain a ketone and have the molecular formula C5H10O. We're asked to give the IUPAC name for each isomer. And lastly, we're asked how we could distinguish between them using carbon-13 NMR spectroscopy. And so there are three different constitutional isomers here that fit this molecular formula C5H10O and have one ketone. And so the first is going to be this one. The second is going to look like this. And lastly, number 3 is going to look like this. Okay, so here are our 3 constitutional isomers. So next we are asked to name each of them. So this first one is a straight chain, and it's a 5-carbon chain, and there is a ketone on either carbon 2 or 4, depending on which side you start counting from. And remember, we always want to give these the lowest number possible. So this is going to be 2-pentanone. Pentanone. Okay. So likewise, the second one is a straight 5-carbon chain. And regardless of which side we start counting from, the ketone is on carbon number 3. So this will be 3-pentanone. The third molecule, the third constitutional isomer, is not a straight carbon chain. Well, so it is, right? But it's not a five-member chain. It's a 4-member chain. So this is going to be named as a derivative of butane. And between the ketone and the methyl group, we want to give the ketone the lowest number possible. So we'll make this 2-butanone. And then, as I said, there's also a methyl group to account for. So this is going to be 3-methyl 2-butanone. Okay, and so lastly for this problem, we're asked how we could distinguish these by carbon-13 NMR spectroscopy. And so remember, in 13C NMR, we're going to see one signal for each unique carbon. So we just need to look at the number of unique carbons in each of these. So for the first one, for 2-pentanone, every single one of these carbons is unique. So 5 carbons, all unique. So by 13C NMR, we will see 5 signals. And remember, we don't see splitting in carbon NMR, so it'll just be 5 lines. For 3-pentanone, the second molecule, there is a line of symmetry through the center of the molecule, so only 3 of these carbons are unique. So we will see 3 signals, 3 lines. And then lastly, for 3-methyl 2-butanone, both of these carbons that I've numbered 1 are identical, so they're only going to give a single signal. And then there are 3 additional unique carbons, so this is going to give us 4 signals. And so obviously we could throw whatever we have in a carbon or in an NMR tube and take a carbon NMR of it. And depending on how many signals we see, we could tell which of these we're looking at. And so that's the answer to Chapter 21, problem number 10.